Okay, everybody, welcome. We are going to be talking about Skill 7 today, which are the 7 different kinds of organic reactions. So we've already talked about some different reactions already. We've talked about synthesis reactions. We've talked about decomposition reactions. We did single replacement, double replacement. We did redox. And we also talked about combustion reactions. So we didn't put it in this category before, but combustion reactions are actually a type of organic reaction. And they're an organic reaction, as we'll remind ourselves a little bit later, because they are only including organic type molecules. So the 7 different kinds of organic reactions, we're going to talk about those today, but you can memorize or help use a mnemonic device to help you remember these reactions, and that mnemonic device is PS FACES. So let's just start at the beginning and talk about the first reaction, which you should know, which is the polymerization reaction. So a polymerization reaction is making a very large molecule by bonding much smaller molecules together. So an example of this one would be if we took an alkene, such as this. So this is ethene. And if we took something like 3,000 of these things, so I'm going to say let's have N equal to 3,000. And if I have 3,000 of these molecules, and I can somehow connect them all together, then what I would essentially force to happen is that all of these carbons are going to eventually bond each other in one big long line, and we're just going to represent that with parentheses around all of these different ethane components, and that ethane is going to now repeat 3,000 times, and so you have one big long molecule of ethane instead of 3,000 individual units of ethene. So there's a whole bunch of natural polymers that you guys have probably seen and talked about before. So one that you might remember from previous is DNA. Also, proteins are a great example of a polymerized subunits that have been put together and to create one big long molecule. And another example are starches. So what's inside your potato? That is a starch, and that is considered a natural polymer. So another example of some synthetic polymers are things like polystyrene. So your polystyrene cups, those are actually big long chains of molecules that have been put together to make the polystyrene cups or plates that you make. Also nylon, so nylon fabric, that's a great example of a synthetic polymer. And silicone, so this is not silicon as in the element, but silicone. Silicone is a type of plastic that can be made and to be really heat resistant. So your hands won't get hot if you were to put a glove on that was made of silicone and then try and take something out of the oven. Those are often made of silicone because they're really heat resistant. Okay, so that's a polymerization reaction. It's just taking a bunch of small things and putting them together to make one big thing. All right, so the next thing is a substitution reaction. Okay, so a substitution reaction is taking hydrogen atoms and they are being replaced by some other atom or functional group. So this is only going to be true for alkane types of molecules. So you can only have saturation happen if one of your reactants is an alkane. So your reactants have to be an alkane. So an example of this would be if I have ethane as my reactant. And let's say I want to react it with something like chlorine, so Cl2. So this is going to create a new type of product where one of these chlorines replaces one of these hydrogens. So it substitutes in place of that. So now I would have still looking like an ethane molecule, but now I would have a Cl atom attached, and now I create a new molecule, HCl, as a product. So this is a substitution reaction where one atom chlorine replaces a hydrogen atom. Okay, next type of reaction is called a fermentation reaction. So a fermentation reaction is one where sugar gets broken down into very specific molecules, and it always is broken down into alcohol and a carbon dioxide. So really this is what makes wine, beer, and bread into what it is. Makes wine and beer alcoholic, and it's what gives bread the consistency that it does. So sugar, C6H12O6. You guys know this as a glucose molecule. That's what this is. So this other molecule here, C2H5OH, hopefully you would recall from what we've talked about earlier that because of this OH functional group here, that this would be a alcohol, or more specifically, because it has two carbons, this is ethanol. And finally, we have carbon dioxide as the other product. So every fermentation reaction in the world is going to take glucose or some kind of sugar, so it could be sucrose or some other sort of sugar molecule, turn it into alcohol and carbon dioxide. And of course, just in case you're curious, we would need to balance this out to make this an appropriate reaction by putting 2's in front of our products there. So that's a fermentation reaction. Always sugar into alcohol and carbon dioxide. Okay, next we have an addition reaction. So an addition reaction is only ever going to take place on unsaturated hydrocarbons, which means that it would be something like alkanes or alkynes. Alkenes or alkynes. And the way that this works is it takes something and adds it across the double bond. So let me give you two different examples of how this might work. So the first example would be if I had this ethene molecule, and if I wanted to add in chlorine, Cl2. Now this is a different reaction from what we saw up above in substitution. These two things are not the same thing. Substitution only occurs with alkanes. Addition reactions only occur with alkenes or alkynes. So if I have an alkene like this C2H4 and I add in chlorine this time, what happens is these chlorine atoms add onto each of the carbons in place of that double bond. So what would happen would be something like this, where now the chlorine is attached to each of the carbons, and there is no longer a double bond in place of that, in between those two carbon atoms. Okay, the other example, you can do this also with hydrogens. So again, if I had my ethene and I added in hydrogens, now I would essentially make ethane. Again, no double bond in between my carbons now, because I have added in this hydrogen molecule, and it has now taken over in between that double bond, and one hydrogen attaches to each of these new carbons. So this is the new hydrogen, and this is the second new hydrogen. Okay. So now on to combustion reactions, which you are all familiar with from previous units. So combustion reactions, this just means two things burning. And for things to burn, you have to have oxygen present for that to happen. So the one that we've talked about already is this example where it's called complete combustion, where you have more than enough oxygen available, and you will always make CO2 and H2O as your two products. So I hope you guys recognize that this needs to be balanced properly. So the balancing here would be, oops, excuse me. Let me erase that. Okay. So if I balance this, this would need to be a 5, a 3, and a 4. Okay. You can also have something called an incomplete combustion reaction. So incomplete combustion is when you have a hydrocarbon and oxygen, but instead of making carbon dioxide, it might make just carbon monoxide because you didn't have quite enough oxygen to make this happen. So this one would also be balanced in the same fashion, where we need to go in and give this the full balance, 2, 9, 8, and 10. So hopefully you can figure out how to do that based on what you've learned previously. Okay, moving on to the next page. So on the top of the next page, we have our last two reactions that we need to be aware of. So the first one is an esterification reaction. So this is making an ester. Esterification. So all you need to know about this is that it's the combination of an organic acid, and so we can represent this as that R group that we've talked about, and then COOH. That is the organic acid. And then we can combine that with an alcohol, ROH, that is the alcohol, and this will always make the ester, RCOO with another R. That is the ester group. And then the product is always going to be water, the second product. So that's just an ester. All you should know about this is that it is an organic acid combining with an alcohol to make an ester in water. That is the big take-home message for an esterification. And last but not least, we have saponification reactions. Saponification. So saponification, your big take-home message here is this is making soap. And soaps are made by combining an ester. So again, an ester would be something that looks like COO with that separate R group, combining with a base. So remember, a base would be something like a metal plus an OH group. And then that will always make an alcohol, ROH, and another product, and this other product will always be a soap molecule. So those are the take-home messages that you need to know for your 7 different organic reactions. Hope that was helpful. So I will let you fill in your summary of all of the different kinds of reactions that we've talked about so far, the synthesis, decomposition, single and double replacement, plus the 7 reactions we've learned here. You should know the general formula and be able to recognize when one of these is happening or not. So that's it. And on the next slide, I'm going to give you the answers to each of the multiple choice questions. I would encourage you to try the multiple choice questions on your own first, and then you can check your answers with the rest of the recorded assignment. Okay. I'm just going to be giving answers here. I'm not going to go through the full explanation. So if you have additional questions, you should come and chat with me about them. So here are your answers. If you see a mistake that I make, please let me know. But I believe these are all correct. Okay, and I will also give you answers for the next sheet as well. Okay, so this type of reaction must be an esterification reaction. This is a COO with 2 separate R groups. R, this is R right here. And then it's got the COO and then a separate R group that is different. That is this part of that right there. And then the water was the final product there. Okay. So reactant 2 must be an alcohol. And if I were to draw an isomer, I think the only available isomer of that reactant 2 would be to place the OH in a different position, and the only available option that would make it a different molecule entirely would be to place the OH on the center carbon now. Okay, so for question 15, this, hopefully you would recognize that because this is a double bond here and I'm adding in this molecule Br2, that this is an addition reaction. So for this addition reaction, I should see 4 carbons they're going to have hydrogens in all the same places that they're currently. And now the Br adds in place of where the double bond was. Okay. Question 16. This is an ester. Question 17. This is an addition reaction again, because C4H8 is an alkene. And so it is asking me to draw the structural formula for the 1,2-dichlorobutane. So again, if I add in my 4 carbons in a row, and it's telling me that I have to have chlorines on the first carbon and the second carbon. And now I can go in and fill in my hydrogens everywhere else. Okay, lastly, this reaction must be a substitution reaction. And it would like me to draw the formula for the final product. So again, this is a butane reaction, or butane product with all my hydrogens. And since this is not specific anywhere, this chlorine could have been anywhere on any one of these carbons and replaced any hydrogen, but just for sake of clarity, I'm going to put it there. Okay, so that is it. I hope that was helpful in explaining your chemical reactions, your organic chemical reactions.